All right, hello everybody, and welcome to the Kubernetes SIG-Windows project maintainer talk. I'd like to introduce ourselves. My name is Mark Rossetti. I've been involved in Kubernetes since about 2019. I primarily focus on making sure Windows workloads work in Kubernetes, but kind of as a result of that, I've dabbled in all sorts of different areas in Kubernetes. Yep, I'm a software engineer at Microsoft, and here's JR.
Hey everybody, my name is JR, working Red Hat in OpenShift, maintaining Windows Node across the OpenShift ecosystem. So for today, we're gonna do a little bit of refreshment on how Windows Node is been evolving within the Kubernetes ecosystem. Also, what's new, a feature spotlight, a couple of features that we would like to for you guys to see how it works in real life. We're going over the contributors, and most important, we're going to point out how can you help in the community to make open source a better world in the Windows side of the house. At the end, we're going to have some time for questions, and we're going to share the resources that we're going to be reviewing today. So Windows nodes in Kubernetes. Since CNCF and all the foundation, Linux Foundation basically is a vendor-neutral approach. Involving Windows as part of the Kubernetes ecosystem has been a great effort. It graduated stable in 1.14, which is like 2019 probably. And one of the key elements is that in order to run Windows workloads with Windows Node, you need like a Windows control plane. It basically reuses the same Linux control plane. Here I'm just highlighting a couple of alternatives where and how you can bring Windows Node into the Kubernetes ecosystem. For example, if you are in the major cloud providers like Azure, AWS, and GKE, you will have like their mechanism in order to get a Windows Node across of the Kubernetes specific implementation that they provide. In the other hand, if you are looking for a more like cloud agnostic solutions on how to get Windows Node, you can go with the Red Hat offering, which is inside the OpenShift cluster. You could install the Windows Machine Config Operator. That will basically give you the ability to have a Windows node, no matter in what platform do you have, or do you have to deploy the OpenShift cluster. There are similar alternatives from Rancher, Tansu, and many others that probably won't fit in this slide. As part of the ecosystem integration that do provide support for Windows, there are CNI integration for networking, Calico, OVN Kubernetes, just to mention a few. As part of the observability, we do have very nice ways on how to extract metrics from the Windows node, just using the Prometheus integration provided by the Windows Exporter plugin. And there are also integration with Datadog, OpenTelemetry, and so on and so forth. Now I will hand back to Mark on the what's new.
All right, so we're going to cover some of the, just a little bit of the work that we've been focusing on since the last project update, which was KubeCon Salt Lake City last year. One kind of area of work was really focusing on kube-proxy enhancements. Just like all the other Kubernetes components that run on the node, we maintain the kube-proxy implementation, and there was kind of a lot of work that had kind of backpiled up on this, including a couple of feature gates, which were written before the KEP processes were started for this. So we ended up writing a retroactive KEP that described all the functionality for how overlay networking works when it's configured in a Kubernetes cluster, and also direct service return support. And kind of as a result of that, we really overhauled the documentation for how Windows networking works with services in Kubernetes. So it's kind of a little bit of a spelunking exercise, but I think a lot of good work came out of that. Next is we've progressed graceful node shutdown for Windows from alpha to beta. This feature was implemented in Linux and driven by KEP. There was a shorter KEP to kind of handle the Windows implementation of this too, and this is kind of a very important operational enhancement for this too. So after this work, just like on Linux, if you're on a systemd-based system, if your Windows node receives a Windows shutdown signal, we'll inhibit that and go through a series of kind of controlled pod shutdown sequences to make sure that your workloads have a chance to clean up. I will call out too that previously, the guidance for running Windows, that kubelet in Windows was to use a third-party service manager like nssm.exe, because it did get a lot of kind of systemd-like behaviors like consistent logging and things like that. As a result of this work, and because we need to receive a shutdown signal, and the only way to do that on Windows is if you're running as a Windows native service, we've changed that guidance. So now we recommend running the kubelet as a Windows service. But to kind of keep all of the nice operational functionality, we've made a lot of enhancements to kubelog runner to do things like log rotation and log streaming and things like that. So we're recommending to use that in conjunction with this, and that's all called out as part of this enhancement. Another kind of big focus on Windows is just CI signal for Windows. So over the past couple of releases, Yuan Liang here has done a lot of work to get the Windows Node E2E tests running in Kubernetes. If you've ever kind of contributed to Kubernetes, you'll see test grid, which is a huge collection of all of the different CI jobs that are run here. And there's many different levels of CI in the project. There's unit tests, integration tests, E2E tests, which actually spin up a cluster and simulate workloads in the cluster. Node also has a majority of the kind of node-specific functionality behind these Node E2E tests, where a node is brought up, a container runtime is started, and kubelet is run in a headless mode. And then kubelet-specific features are exercised there. We've got this all running on Windows and have a CI job running. To validate this, we're still working with SIG-Node to just kind of get approvals and make sure we've got the right separation of concerns in there. But this was a lot of work, and it's going to greatly enhance the test coverage, and it also makes it much easier with guides on how to debug the kubelet on Windows Node locally, which has been a big pain point historically, because we can't run things like kind. And this isn't something that's happened in Kubernetes itself, but I did want to call out that now we have stable CI coverage with Windows Server 2025. This is kind of, people have been asking for this for a while, like what's the status of this? I will say there were some networking issues that are finally resolved with the October 2025 or 10b patches that may affect your pod networking if you are running in overlay networking configure mode. So those have finally been released publicly, and we think that that's kind of the last step in getting your Windows Server 2025 workloads running stably in the cluster. We've talked about this in the past too, but I did want to highlight that historically one of the pain points of running Windows containers is that for process isolated containers, which is what Kubernetes runs and what most of the containers are built for, you needed to build the container targeting a base image that matched the host OS level. So if you wanted to run if you wanted your node pool to be Windows Server 2022 images, you needed to build your containers off a Windows Server 2022 base image. And if you wanted to upgrade your node pool to Windows Server 2025, or I guess a better example is going from Windows Server 2019 to Windows Server 2022, you need to rebuild all of your container images targeting that new base OS. Starting with Windows Server 2025, there is what we're calling portability for Windows Server containers, where your current host can run N-1 versions of the Windows container images built on the N-1 base. So you can have all of your workloads that are running on Windows Server 2022, targeting Windows Server 2022 base images, just run on Windows Server 2025. And I believe there's that support will be carried forward too to make it easier to do upgrades. So that's a big improvement coming from the Windows team. Next, I want to talk a little bit about the roadmap, and we're actually going to get more into this in the future too. But we do have kind of a backlog of enhancements that are either in alpha or beta functionality. So the next couple of releases, we're going to work on kind of fleshing that queue. Another big kind of set of work and ask that we've seen is the in-place pod resize work. So for those, this is already, I think it went GA in node this release. But for those who aren't familiar with this, this allows you to add more compute or like CPU or memory resources to a pod. So if you're running a workload and you need more resources for it and you don't want to disrupt it by rescheduling the pods either on a different node or with different resource sets, you can just add more resources to that. This work is supported in container D, so it's already plumbed through the container runtime. We just need a little bit of time to wire it up and test it in the kubelet and hope that bringing the vertical pod autoscaling functionality in addition to the existing horizontal pod autoscaling functionality to Windows will help with flexibility. We'll talk a little bit more about future work later in the talk. But now I actually want to bring up Yuan Liang, who's here to talk about some of the work that he did for graceful node shutdown.
Okay. Yeah, for graceful shutdown, because live demo we wait for the timeout interval to be expired. So we pre-done some tests and record the screenshot. In our test, in order to demonstrate the graceful shutdown, we create a few pods. Some of them with normal priority level, the others are with system critical priority level. So we want to show that after the node is shut down, it will initiate the pre-shutdown event, and Kubernetes, after got this event, it will trigger its process to kill all the pods, and in the order we expected, which we will kill the non-critical pod first, and then the critical ones. So in the beginning, we can see that all the pods we created are in the running state. And then, And then we initiate the shutdown to one of the Windows node. And after some time, it will get triggered. And then we can see that the pod starting to get to the error state, which is the expected state. So you can see from here that it started from a non-critical pod. One of them is in the error state. And then later, all the pods we created will get to the error state. And after that, and at that time, if we check, we can see that the Windows node is in the not ready state. And after that, we reboot the Windows node, and the node will get back to the ready state. And if we check the pod at this time, we can see all the pods get cleaned, no leftovers in the system. Yeah, basically that's the test we want to show. Yeah, thank you. Get back to yeah.
All right, so another feature that we would like to go with you all is the no-log query. And this feature is actually been around for a while. It went on beta in 1.30, and you can use it as is right now. So what is no-log query? No-log query basically will let you view and query logs for any Windows node and any Linux worker node. How it works behind the scenes is it queries the kubelet API and extracts the logs directly from kubelet. In order to get this feature in your current cluster, it is behind a feature gate, so you need to enable the feature gate. Of course, the name of the feature gate is no-log query. Once you set the feature gate to true, then you need to make sure that your kubelet configuration also entertains the log handler and the log query also in true. Once you have the combination of these two options, then you will be able to hit the log proxy endpoint behind the kubelet endpoint. Since everything happened within the Kubernetes ecosystem, you will have the ability to all the RBAC checks, the RBAC authorization, everything will be in the safe way. This is how you can use it. Right now, you do kubectl get raw, and you add the proxy logs endpoint. You add the option query, and in this case, I'm querying a service with the name kubelet. So in this case, I'm targeting a node where the name of the node is node-1. And what it does behind the scenes is, and this is how it works, the separation from different behavior on how it works on Linux node or the Windows node. The same query, for example, if you go for a Linux node, it will query the journal in order to find a service that is running that match the name. From the Windows side of the house, it will we're trying to find a service in the Windows event log. So if there is no output from that, it will go back to the file system and try to find a service in these specific directories and the combination of directories file name .log. The Windows equivalent for sure will be c/var log. So the conclusion on this is that you no longer need to guess the log's location across different services or operating system. It brings consistency in the way you could extract logs from the nodes. And most important, you don't need to have an SSH connection into a Windows node, for example, in order to extract log from it. This is an example on how you could debug like worker node at scale, no matter if they are Windows or Linux worker. This is like a one-line command. It is a long one, but it could be a one-line command where I'm doing a loop on all the names of the nodes that have the role worker, and then I'm hitting the logs proxy endpoint for each of the node, querying for a service that name my cross-node service, and I will get a match on all the lines in the logs that have the word error, and it will bring me the last 5 lines for each of the nodes. There is a better way on how to use it. There is a kubectl plugin that was published in order to make your life easier in a more user-friendly way, that you don't need to like copy and paste the full API URL every time that you need to use this. You can install the kubectl plugin that goes by the name no logs, and then you will have full access to all the options that the API provides. Ways on how to install the plugin, you could go manual binary download, build from source, or my recommendation is just to install it by the crew index. It's been published in the crew index itself. So big kudos and credit to Arvin that made this plugin possible. And so let's go through a quick demo so that you can see working. So right now I have a OpenShift cluster with 2 working nodes. One of them is a Linux node, and the other one is a Windows node. In this case, I'm just picking the name of the Windows node, and what I'm trying to show you right now here is the kubelet configuration for that specific node. So in this case, it may be a little hard to see the full output, but let's see if we can get the specific configuration that we need out from the node. In this case, we do have the feature flag on and also the kubelet configuration option that we need to. So basically, that gives you the ability to query this node with the no log query feature. In this case, I'm using the API in order to get all the files that I have in this Windows node. But what happens if I need to query a service that is not present, that have no logs present in the files? So this is the way on how to do it. You use the option query and you pass the name of the service that you need to look after. In this case, I will bring the last line for this Windows service. And here you can see how it works on a Windows node specifically. So let me go back. This is the demo, so I will pass it back to Mark for a next session.
Okay, I think we want to use a little bit of time to recognize some community contributions too. This one in particular is like really fascinating. There's so much detail in here. There was an issue where certain Intel processor families would have a kubelet panic if certain volume attributes were set on a storage volume. And we were seeing this across multiple cloud providers. And after like several months of just kind of digging at it, some folks at EKS kind of root caused the issue to be a null deref in a kube log statement. So like this just really interesting. I just wanted to highlight and really give a big thanks to those folks there. I also wanted to spend a minute to talk about some leadership updates we've had in SIG-Windows. So over the past year, James Sturdivant from Microsoft and Amim Nabin from Broadcom via VMware have kind of stepped down as leadership out of their leadership positions. But we've had a chance to welcome Yuan Liang, who came up on stage as a tech lead for SIG-Windows. And I also want to talk a little bit about how kind of you all can help contribute. So as I mentioned before, recently the amount of kind of enhancements coming from SIG-Node have just exploded, and that's left a lot of room for, or that's left a lot of KEPs that have kind of Linux-specific implementations with room for Windows implementations in them, but that Windows functionality has not been implemented due to just the amount of time, contributor bandwidth. So I do want to say that this is a great way to kind of get introduced into the Kubernetes ecosystem if it's something that anybody's interested in doing. With the SIG-Windows, you can go kind of as horizontally or as deeply as you want in your contributions. If you're interested in networking, storage, just like CPU management, all of that, you can kind of, there's room for contributions in that as well. And I also do want to say that a lot of the SIG-Node enhancements that are missing the Windows functionality, those are like very visible features that can be implemented without needing to author and progress a KEP. For anybody who's new to Kubernetes, who's had to go through the KEP authoring process, it can be very overwhelming for new contributors too. So if there's anything that you're interested in, like just join, well, we'll talk about how to reach out to us too. Another thing I want to highlight is that many of kind of the ecosystem tools like CNIs, observability plugins, and things like that, those are normally run by scheduling a daemon set to your cluster, and a lot of those are missing Windows implementations, but can very easily be adapted to support Windows workloads too. So probably 10 releases or so ago, we introduced host process containers in Kubernetes, which are essentially privileged containers. They run by being packaged up like a container, but will spawn processes on the host. And that's enabled us to do a lot of, to really get parity in that space. Whether you want to run your CNI, your kube-proxy as a daemon set, your CSI drivers, Windows Node Exporter, all of that. We've found that many of these projects just aren't aware of this functionality, and actually like adding support for these is as simple as setting a new Go like cross-build target and then making a simple container image and adding it up too. So that's a really good way for us to kind of get more exposure and more parity with Linux. And a lot of times we're just not aware of what people are using. So if anybody is running things, observability tools, like management tools or anything like that, please reach out and we can either like help you kind of bring that support to your Windows nodes too. And we're also just interested in what like all of your use cases for Windows nodes. Again, going back to, there's just been an explosion of KEPs and functionality coming from SIG-Node. We're honestly not quite sure where to prioritize the work too. So we'd really like to hear from you. Just like every other SIG in Kubernetes, we have community pages with links to our meetings, times, agendas, how to contact us. And we have a contributing page, which helps you build and run tests for the kubelet, kube-proxy, all of the different Windows components to get started too. So we'd like you to kind of read through that, and if you're interested, join one of our community meetings or reach out to us on Slack. And now I think we have a little bit of time for Q&A, but we also do have a survey. Do you want to spend a minute to talk about the survey?
Yeah, I mean, one of the key elements that we need to like looking from you all is like how are you using it, if we are using it or no, and some feedback that can help us on how can we better provide the developer tool experience that would fit the specific environment that you are worried about for Windows specific workloads in Kubernetes. So we just put in a quick server. It may take you like a minute and a half to fill it in. So we encourage you to provide any feedback that you can. It will definitely help. Yep. If you have any question or comments, we could enable a mic down there.
Or just reach out to us after the talk.
So first, thank you for the talk. You mentioned kind of the work that's upcoming and needing to get more contributors there, and also the fact that not all components are being built for Windows regularly and everything. What do you see as the biggest technical challenge for Kubernetes users who are using Windows containers that are going to be upcoming in the next 6 months or a year or whatever?
I think for me personally, a lot of one of the biggest challenges is just stability. The past release have spent a majority of my time just fixing a lot of those test jobs, running, updating, making sure the unit test jobs run smoothly so we have a clean release signal in SIG-Windows, because we are as part of the official Kubernetes release. But with kind of the flood of Linux features, it's pretty easy to things should mainly work the same on Windows and Linux, but they, reality is never kind of as pretty as that too. So keeping up with that too, and then I think, yeah, kind of like what we said, just figuring out what features make sense to implement for Windows and what would really help kind of Windows containers, help our customers continue to run Windows containers.